Hi, good afternoon. I'd like to I hope you noticed the track they were playing there was Ain't Nobody Does It Better by Chaka Khan and Rufus, 1983. I'd like to think they chose that for me, but I happen to know it was on Random Play, so it's not. So hello, I am what's left of Quentin Cooper, tweeting us at QWERTY. I've been him, and I've been here since 10 a.m. when we had FameLab International Tremi Final 1. That was followed by Tremi Final 2, and as you've probably figured out by now, this is the third and final Tremi Final. So we start with a quick quiz. First thing I need to know, who has been here every faltering step of the way since 10 a.m? Hands up. Yay, round of applause for these hardy souls. You are the elite, the elect, the select, and or the ones with a lot of free time. Right now, who was in one or other of the other Tremis, but not both? Okay, yeah, smaller group, you know, it's okay, but you don't kind of rave applause with it. And most importantly, who is here never having been to any kind of FameLab before and isn't quite sure what kind of polymorphous amazement you are in for? You, just you. That's great. Well, that's great. There's a couple of you. Great. Okay, well, look, you're most welcome. You're in for some fun. Essence of the thing, mostly you'll pick it up as you go along, but basically this lot get 3 minutes to amaze us, daze us, overwhelm us in various ways with the magnificence and significance of science. The judges get a couple of minutes to question them, and then we move on to the next person. There's some other stuff you'll pick up as we go along. There's no PowerPoints, no hoverboards, no other electronic aids involved, bribery forbidden, heavy machinery forbidden, everything else quite clear. So far, we've had champions from Bangladesh, Egypt, Korea, Malaysia, Romania, Thailand, and the UK, who have all booked themselves a place in tomorrow night's final. That's 3 sent through by the judges, plus a bonus one sent through by the audience, because the audience get a vote. If you vote the same as the judges, as they did in Tremi Final 2, that's the way it goes. If you vote different from the judges, an extra person goes through to the final, and the final gets longer and even more competitive tomorrow as well. So now this is the longest of the Tremi finals because the other two had 8, this one has 9. And again, we have to whittle and winnow and weed them down to 3 with the help of our judges, which is what we're going to welcome next. So we've got highly skilled, highly thrilled judges. If we can welcome them to the stage with a burst of applause, that would be great. First, Cambridge-based freelance science writer and presenter who studied all sorts of things before, as she puts it, discovering a love of brains and specialising in psychology. Ginny Smith. Next, broadcaster, filmmaker, conservationist, and according to her biog, a Welsh wildlife biologist, which could mean she's from Wales or that she only does biology from Wales. Lizzie Daly. Which one is it?
Scientist, I think. Another breed. Yeah, another breed.
Another breed of scientists. And finally, long-serving science communicator here and in Cyprus, former FameLabber and a lecturer in applied mathematics at Cardiff University, Katerina Cowrie. So, Ginny, quick refresher. What are the criteria on which you will be passing judgment on these FameLabbers?
So we will be looking for 3 C's: content, clarity, and charisma. So that means we'll be looking at what they're talking about, we'll be looking at the way they talk about it, whether we can understand it, whether we are following everything, and whether they're keeping us engaged. And we will be looking at them, I guess, and the way that they draw us into the story.
It's how much they radiate as,
yes.
as they talk to us.
We should not be able to take our eyes off them.
Yes, much like me. Lizzie, and how much judging emphasis is there going to be on the bit where you get to ask them questions? Because presumably, all their presentation skills are pretty good, otherwise they wouldn't have got this far. They've got through national heats and semi-finals and finals, and they've made it all the way here. So what kind of nature of questions are you going to be going for to tease the difference between them?
Yeah, so after each of your 3-minute presentations, we'll have about 2 to 3 minutes to really look at your research, to try and get under the skin of, why you're doing that research and its importance and its relevance. So it's really an opportunity for us to kind of take it to a deeper level and really get an understanding of why you've chosen that research.
And Katerina, when it comes to the final decision, is it science value always top entertainment value? I'm thinking particularly a couple of years ago, we had somebody in the Tremi-finals who gave a really amazing presentation about 50 shades of epigenetics dressed in full bondage gear and with a whip. But they didn't make it through to the final because the judges not unreasonably decided that they thought some of the scientific content wasn't 100% accurate. But I always felt sorry for the audience in the final who never got to see this brilliant presentation. So will you balance entertainment in there as well, or is it just science all the way?
I think entertainment in FameLab is key. So we'll definitely take it into account. I'm guessing it goes under the charisma criteria. So when we make the decision, we're going to be balancing everything together to get somebody, the 3 people that go to the final, that they are also entertaining, but also they have the 3 C's that Ginny said.
Brilliant.
Yeah.
And you'll have to do it very quickly when we come to that part. Okay, so rejecting 66.6666, you get the idea, percent of this star-spangled assortment. Not going to be easy, so can we give the judges a kind of warm glow of applause, please, just to show our appreciation of their task. Okay, we've had the high-speed history, we've rattled through the rules. I think we are all revved up and ready to go, particularly because my energy levels are beginning to drop. Only 2 things to remember. 1, whatever doesn't make sense, we'll do in a couple of minutes' time when you've seen the first FameLabber. And secondly, this is FameLab, not Fame Library. Don't be afraid to make some noise. Can we have a little demo noise from the audience now? Excellent. I want that as a kind of minimum entry level, okay? So the order is random, and we start by chance with our furthest flung of all 25 of our FameLabbers, our winner from Australia, Paolo Magni, who's already come nearly 15,000 kilometres to be here. Although, to be fair, she'd already travelled about 13,000 kilometres to get to Australia in the first place, because Paolo was born and raised in Turin, went to Oz for her PhD, and is now a lecturer and researcher in forensic science at Murdoch University in Perth. Now, her speciality is insect investigations, forensic entomology. Now, that doesn't mean she's bugged bugs and has files on flies and runs sting operations on bees, but it has involved Paola's expertise in cases of homicide, suspicious death, and animal cruelty, and she's even developed an app, Smart Insect, to help pathologists and investigators at crime scenes. It's apparently been downloaded over 10,000 times. I don't know if that means it's helped solve 10,000 crimes, but that's still pretty impressive. Now, you don't need to be a detective to know it's always an extra pressure going first in the final. So can we have some ostentatious Aussie applause, please, for our 2019 FameLab Australia winner, Paolo Magni.
Can be pretty frustrating because every single case is unique. The time, the place, the people involved, the evidence, they're always in a different combination, making the investigation extremely difficult. In my experience, the most challenging cases are when human bodies are found in the ocean, because the water moves and can move the body from a place to another. The water washes and can wash away the evidence. And the water is full of fish. We use the body as food. In this type of investigation, we really had to think out of the box. So forget about the pipe and grab a snorkel, at least. And this is my research about finding revolutionary tools for forensic underwater investigation, like this. When a human body is missing in the ocean, it's often all dressed up. Fish are interested in the flesh of the body, not in the shoes. Fish are scavengers. They ride, they eat, they live. But there are other animals called colonizers who arrive and stay forever or until their body is discovered. Animals like these, barnacles, crustaceans like lobsters and crabs. But guess what? Barnacles are like me. They love shoes. So in my research, I placed underwater hundreds of sporty shoes and elegant shoes. And I found that, well, barnacles actually have a preference for elegant shoes. But not just that. The species of the barnacle can tell us where the body comes from. The size of the barnacle can give us information from how long the body is in water. And the chemical elements in the shell can help us to backtrack the journey taken by the body in the ocean. So the barnacles can be a powerful tool for forensic underwater investigation. But forget about the shoe and think big. Big like a plane. A plane with more than 200 passengers mysteriously disappeared in the ocean. What if I tell you that the wing of this plane that was found months after the disaster was actually covered by barnacles, the same barnacles on my study? My research is a global application because it can be key to solve many criminal cases. Where is the plane? Where are the missing bodies? What about cases of piracy? And also cases of human and drug trafficking through the ocean. You see, some people need handcuffs to catch a criminal. I'm different. I use a barnacle.
Thank you for that. How quickly after something enters the sea do barnacles colonize it? Is it pretty imminent, or does it take a while?
Yes. In our experiment, we found that in less than 15 days, we already have barnacles attached to the shoes. But they have preferences, so you have to choose the type of shoes. You have to think like a barnacle.
And how precisely can you tell how long the barnacles have been there, or where it is, where the shoe has been?
So there are tables of growth of different species, so it depends if this table of growth has been studied or not. Some species are more common and more well-known. I mean, barnacles have been studied by Darwin, so we have data from Darwin, but obviously Darwin didn't go to Sydney, so the Opera House barnacle has been not studied by him and by anyone else because it's been actually found and discovered only a few years ago. So it depends what we find. We can be more or less precise. Said that, sometimes we have colonization of different barnacles, so we can narrow more if we have more species, or we can use just a specific species to give more information.
Okay. What is your takeaway message from your research and your talk?
Well, the research that I did in this case is about elegant shoes and sporty shoes. And the reason why I did that is because I worked on two real cases, or two missing people that we found in the ocean, wearing, in one case, elegant shoes, in one case, sporty shoes. So with our research, with my research, we were able to give closure to their families because we gave information from where the body, what was the primary crime scene, and from how long the body was in water, and every movement that the body had in the water. It was a criminal case, so I cannot speak too much about that, but was good because the barnacles are just little creatures, but they can give peace to families.
Thank you.
Okay, putting the C into CSI, our far-flung Oz winner, Paolo Magni. If somebody here, we're pretty close to the Cheltenham Literature Festival here, somebody isn't here taking notes of creating a series of detective fiction based around this. I can see the title of the first one, High Heels, Low Water. I also love the line, forget about the pipe and grab a snorkel, which might be my favourite one-liner of the day. Right, who's next? Oh, no need to check. It is our Czech Republic winner, Lukáš Marishka, a PhD student at the University of Chemistry and Technology in Prague, specialising in microbiology and biochemistry. Lukáš also works for the Czech Academy of Science at the Institute of Experimental Botany. Experimental botany, that sounds like creating triffids, which I'm really hoping he doesn't. Lukáš says his mission is to contribute to the protection of nature and improve the ways people treat Earth, which is quite a mission with or without triffids. But the next 3 minutes, he hopes, will go a small way towards it. Plant your hands together for our manic botanic Czech champ, Lukáš Marishka.
When I was a young seed, my mother always said to me, "You are my special one." And then I grew up in the Czech Republic on the field, and I came to realize I am not special one. When I look left, rape. When I look right, rape again. And behind you, don't look there. Oilseed rape is absolutely everywhere. Even in the research. For example, in the Institute of Experimental Botany, they use my brothers and sisters as a model plants. Hey, an agriculture aircraft. I hope it's carrying fertilizer. No. Pesticides again. Pesticides. Not as a good friend to me or to you, as you may think. They destroy the quality of the soil, and the chemicals can find their own way to your food as well. So, why do our farmers use them? It's cheap and easy. But there is a better way. They can use our inbuilt protection mechanism, which can be activated by treatment containing inducers of resistance. These inducers of resistance can be dead microorganisms or their compounds. It's something similar to human vaccination. We plant may look very simple, but when we recognize the disease, we can produce very effective protection. Yeah. But we can't tell if the microorganisms in this treatment are dead or alive, so we start to protect ourselves preventatively. These microorganisms are very dangerous, and it's a big difference between you and me, because you have white blood cells with long-term memory, and a few injections are enough for you, but that's not our case. We don't have any immune memory. We have to be vaccinated before every danger, because for us, it's most important part, the recognition of the danger of the disease. And they are not friendly. They want to confuse us, hide themselves. They never come to my field, never knock on the leaf, and never warn me, "Hey, loser, I'm gonna kill you." But farmers know when these uninvited guests come. With this experience and important scientific research, of course, pesticide consumption can be radically reduced and protect our planet from harm to your children's sake. So please take care about your plants, about us, as well as you can, and we give you everything. Thank you.
Hello. So there was an element of comedy in there, and it's quite a convoluted issue to explain to others or to get people interested in. So how did you go about designing your talk today?
I like plants.
Yeah.
And I like to be plants. Because, yeah, they only stay on the field, on the ground, and do nothing. So it's nice. And the plants are very understandable. Because, yeah, they are simple, but they are not simple. They communicate between themselves, between the space, between the nature, between the pathogens. And it's very interesting. And from my view, it's interesting to tell it like a plant, not as me, as a scientist, which work with them.
Great, thank you.
How did you choose the plants?
The plants I choose because I work with sea grapes, because it's some interesting plant, because in Czech Republic it's everywhere. Around the Prague, around the Bohemia, around the whole Republic. So, yeah, we have plenty of oily grapes. And we have a work with them because, yeah, there is nice system, the pathogen system, which attack the rapeseed oils, and it's clearly visible. And it's the work with this is very simple. Yeah, that's the reason why I choose the rapeseed oil, because I am close to them.
You say that plants can recognize certain pathogens.
Yes.
How?
Yeah, it's quite scientific question. The plants, those are the tissues, and these tissues are made from the cells. Cells have the cell wall, and there are the receptors. which can recognize the danger, they recognize the disease, because when they don't recognize the disease, they die, and they don't want to die. So here is, for example, we have a bacteria which has some part which is recognized by the plant, and when the plant recognizes this bacteria, it produces very, very effective protection as, for example, the radicals, the antibacterial enzymes. And the plant can destroy it, but the bacteria don't want to be destroyed. So bacteria produce the compounds which can confuse the plant, don't recognize the signal. So it's a very complicated system, and it's funny to work on this.
And you'll have to leave it there. Talking crop without talking down to us, our Prague pragmatist, Lukáš Marishka. And as I was explaining, remember the rules, you are limited to what props you can carry on yourself. So this is really going to be you can't be doing this when he's in his 60s, I think. He's going to have to find a simpler routine. Also, by the way, the time starts when you start speaking. So when you're swaying around being a flower, cleverly, that does not count towards it. Next up, it's FameLab Germany and their 2019 winner, Tora Schubert. Tora claims a special link, a connection, a bond with Cheltenham because she studied geosciences at Göttingen, which is Cheltenham's German twin city. Who knew that? Yeah, I thought so. And Göttingen has the motto, Die Stadt, die Wissen, space, Shaft. And if my dodgy German isn't wrong, that means the city which creates knowledge. And it's a pun on Die Stadt der Wissenschaft. That's der, not die, and Wissenschaft, all one word, which means the city of science. Thought you'd like to know that. So there's a science link, a twin city link, and a geological link as well, at least as far as Tora is concerned, because she believes geology is everywhere. Now a master's student in georesources management at RWTH Aachen University, Aachen twinned less impressively with Halifax, Tora entered FameLab to share her multi-layered love of geology with us. And although 3 minutes is barely enough to scratch the surface, let's have a seismic surge of applause and a Tora, Tora, Tora roar for our German champion, Tora Schubert.
We live in troubled times. To deal with climate change, we have to reconsider major parts of our lives. One of them is energy supply. If you're reading about the future of energy supply, you will inevitably stumble across carbon capture and storage. But what's that exactly? Let's break it down. Carbon is the lazy term for carbon dioxide. That's a greenhouse gas, which is substantially contributing to climate change. And I hope that we can agree that that's not good. Then there's capture. Plants capture CO2 all the time. And together with water, they convert it into organic matter and oxygen. Engineers are now looking for ways to capture CO2 technically, right behind big CO2 producers like coal plants or cement works. In that way, the CO2 can't enter the atmosphere and can therefore not have any influence on our climate. But the question that remains is the storage. Where to put that CO2 we've captured? And to answer that question, I brought an expert. Good evening! Welcome you came here to today's episode of Cooking with Rocks. Today we're going to make an exquisite carbon capture and storage. And in order to do so, we're going to need already captured carbon dioxide. I prepared that already. Then we need a reservoir rock, which is porous. The porosity is the important part. I recommend a sandstone. And we need a cap rock, which is impermeable to CO2. I recommend a claystone for that. This cap rock has to be on top of our reservoir rock, and both at a depth of at least 800 meters. Now the difficult part, I want you to pay close attention. Through a tiny hole that we drill into our cap rock, we insert the CO2 into our reservoir rock. We do that with a lot of pressure, so the CO2 becomes supercritical, which basically means that it behaves like a fluid and doesn't take up much space. Then we close our hole, et voila! Sounds awesome, right? Unfortunately, there are downsides. If our cap rock has even the tiniest leak, the CO2 will gas out into the atmosphere, and it was all for nothing. Actually, even worse than that, because the capturing, transportation, and injection of the CO2 are very energy-intensive processes, which produce CO2 emissions themselves. And if we use too much pressure to inject the CO2, then we might induce earthquakes, which might affect the impermeability of our cap rock. So maybe we will be able to solve those problems in the future, but maybe we won't. And therefore, we shouldn't rely on carbon capture and storage on solving our emission problem, and better focus on not producing them in the first place. Thank you.
So what is the key takeaway message from what you want to say to your audience?
It's a technology that might be very useful to humanity, but we shouldn't rely on it because it takes risks we can't control yet. So we should consider more research on it, but not rely on it yet.
Okay.
Have you found any more interesting ways apart from carbon capture at all? Have you come across anything?
There's the whole field called Geoengineering, which includes ideas like putting chemicals into the atmosphere that create clouds to reduce the amount of sunlight that reaches the Earth. But all of them are pretty much science fiction, and we have too much influence that we can't really understand or control. So it's nothing that is applicable right now, and probably won't be in the next few centuries.
Okay. At what stage would you say that climate change gets so critical that it's worth taking some of these risks? Because obviously, you know, the ideal situation is we stop producing so much carbon and it naturally kind of sorts itself out. But we're getting close to the point of no return. When do we say, okay, these risks are worth taking?
Actually, I'm pretty glad that I'm not in the position to decide that.
Me too.
I think as soon as we have found enough, there are sites where it's tried right now. And when there's enough of those sites where it works just fine, and hardly any more with earthquakes occurring, then we could say, yeah, let's maybe do that on a bigger scale. But as long as those test sites are so little numbered, I wouldn't go into mass production of that.
Okay, captivating carbon capture from our FameLab 2019 Germany winner, Tora Schubert. And despite dressing up as a chef during that, Tora Schubert is an anagram of a short butcher. Right, well, next, having gone a huge way northwest from Australia to the Czech Republic and then a little bit northwest over the border to Germany, we again border hop northwest to get to the Netherlands and their 2019 winner, Athira Menon. Now, Athira is a globetrotter. After a PhD in Australia, which, as we've established, is southeast of here via Germany and the Czech Republic, she did a master's in Canada and a BSc honours in New Zealand. Same details as Australia, but a bit further. Before reaching the Netherlands, where she's now a postdoc researcher at Amsterdam University. Actually, Athira is more than a globetrotter. She's a galaxy trotter, a stellar astrophysicist voyaging across space to study the big lives of big stars and their dramatic deaths as supernovae or black holes. And Athira is also more than a trotter of any kind. She's also a dancer, skilled in what many claim to be the oldest dance form in the world, Bharatanatyam, which originates in southern India. So, prepare for some cosmic choreography from FameLab Netherlands champion, Athira Menon.
At the stars on a clear night, do you not wonder, who are we? Where did we even come from? The answers to these questions do indeed lie in the stars. The iron in your blood, the calcium in your bones, the very oxygen we breathe were all formed once inside the hot cores of massive stars at least 10 times heavier than the sun. When these stars are about to die, they explode so powerfully that they can outshine an entire galaxy. We call these explosions supernovae, and it is from their ashes that new stars, new planets, and any form of life can be born. One such supernova went off in our cosmic backyard, and it was so bright you would have seen it with the naked eye for months. We did see it in the year 1987, and so supernova 1987A soon became the most well-observed celestial event in human history. And yet, not one astronomer could explain why it had even happened. Because until that time, all stars were considered to live alone, just like our sun, and a single massive star was expected to puff up to a red giant before exploding. But the star that was found to have exploded as this supernova was the opposite. It was a compact blue star, only 1/10 of that size. A single star that lived alone all its life could not have possibly behaved like this. So maybe the star was not exactly born alone. Maybe the star was born from the merging of two stars that went around each other at some point in the past to become one. And that is the very question I investigated in my research, for which we ran simulations of binary stars and their explosions. And voila, we found that the only conclusive way to explain the origin of this peculiar supernova was indeed through the merging of two massive stars very late in their lives. It seems to me that we have a long way to go in this world, because binary stars have only come into importance today, in this day and age. Telescopes can confirm that at least 70% of all massive stars are found in binary systems with companions, and at least 1/3 of them are bound to merge. We now await the launch of even bigger space telescopes that can look back to the very first massive stars and their explosions, unlocking further mysteries of their lives. One step closer to unveiling their lives is one step closer to understanding the origin of all life. Thank you very much.
What are the challenges with studying something that is so far away and then trying to compare that to simulations you're running here on Earth?
It's precisely that. They're so far away. Our telescopes are not exactly sensitive enough to get through to all these interesting binary systems. Some of them are even triples and tertiaries, they have more than one companion. Data has to come in a lot more, and that's why we're awaiting the launch of the James Webb Space Telescope in the next couple of years, which will look back to that first star that ever was born. So, more data.
And when did you find this out? How long ago was it?
The fact that it's a merger?
That's your research.
This was during my PhD.
Yeah.
So it was a couple of years ago that we confirmed it.
Okay. Mm-hmm. And your presentation, you wanted to tell it very much as a story.
Yes.
And why did you choose to tell this talk in that way?
Oh, because I think astronomy is the oldest science we know in human history, and it started from the caves, and I imagine people were telling these stories around fires, drawing constellations on cave walls, and my inspiration was just to keep with the old times, being traditional.
Thank you.
So with the simulations, you have to do some assumptions following the previous question. So they are not accurate at the moment because you need more data, is that correct?
For this supernova, we were just modeling the progenitor of this supernova, and we had a lot of data about it, precisely because it's the most well-recorded celestial event. So we didn't have assumptions per se for this system. And since 87A occurred, there have been a lot more of these binary systems that have been found. So we're working well with that.
From the Netherlands, an investigated binary stars, so literally talking double Dutch, Athira Menon.
Thank you very much.
And Athira Menon, her name is an anagram of no main heart. And another main anagram of Athira Menon is another main. No, midway, and we're now going to break our North by Northwest homage because we're headed from Ethera to Athens and the 2019 Greece champion Ermis Zakharopoulos. Ermis studies computer science at Athens University of Economics and Business, and he says he's passionate about technology and science and that he's, quotes, always talking non-stop. So he's a Greek geek who likes to speak. And when he speaks in English, what she's about to, don't be surprised if he starts going on about psychic terrain or Z moves or Pikachu, because he claims he learnt English mostly by playing Pokemon on Game Boy. So beware Greeks bearing the gift of the gab, even if it's a Game Boy gift from our very game Greece champion, Ermis Zakharopoulos.
So I've studied computer science, but today I'm going to talk to you about a different kind of network. I want you to imagine a forest, right? So we're thinking of trees laying here and there. They seem independent, minding their own business, photosynthesis and stuff like that. Well, it seems that the world that lies underneath the ground tells a whole different story. This is thanks to the 25-year research of Suzanne Simard from the British University of Columbia, when she discovered that trees are far more alert, far more social, and far more intelligent, one might say, than we think. So what happens exactly is that trees can communicate with each other using a vast underground network of roots, and they can exchange information and chemicals. Okay, so how does that work exactly? We know that trees have very long roots, many times their height, and these roots are combined with roots of fungi. The mushrooms we see in the forest is just a flower. Underneath, there are vast networks of fungi roots that get entangled with the roots of the trees. And they have a symbiotic relationship. They can exchange sugars for nitrogen and phosphorus and hormones. So what happens in the big picture is that the trees in a forest can communicate essentially with each other using the fungi network as a hub. Okay, so they started to look at different behaviors in a forest. So to help you, imagine that I am a tree. Yeah, that's easy. And I'm sorry. Imagine that these are trees too. So this is my muka roots. So I'm connected to two different trees. All these weird structures are my trees. And what happens is that during different times of the year, sometimes, for example, there is very much heat, and the trees need hydration. So the other trees will help them and send them the hydration they need. But during other times of the year, there are types of trees that shed their leaves. I'm sorry for that, I'll pick it up. But when that happens, the other types of trees that don't will provide nutrients for them. So what we have here is that the forest is acting as a single organism. And we can see that trees aren't competing with each other, they are helping each other out. Also, there are mother trees, central hubs in the forest that are connected with many seedlings. And they help them giving nutrients, but also they do things like changing the way that they spread their roots so they can make more room for the babies. I find this really, really exciting, and it brings questions about how we do things like deforestation, because if we take the central hubs, then the forest cannot recover. So I just wanted to say that we know that nature has an intelligence that is yet unexplored in a very big degree, so we should respect and look for it. Thank you.
Hi. You've kind of touched on it, so deforestation, that takeaway message, but can you go a bit more into why you think this research is so important for people to know about?
Well, from what I've looked into, because I've studied computer science, as I said, I think it's more important to look at the swarm intelligence that exists in many different animal living things, like we have the beehives, for example, or fish in the sea, that they individually they present a behavior, but if you look as a whole swarm, then they have all these different abilities, all these different behaviors. And I think that this is really fascinating, and they are just scratching the surface from what I understand. So the implications of the connections they're much more huge than just deforestation. It's about understanding how everything works, because we are a part of it.
Absolutely. Yeah. Thank you. So am I right in thinking this happens between different species of tree, not just the same type?
Yeah, it happens between different species of trees, and they have found the different connection between some types. So they know, for example, I'm not sure of the English names, but they know certain types of trees that will cooperate with each other, and certain others that will. So in a very big forest, you could have like 2 or 3 networks from the different types. So, yeah.
Nice.
And what do the fungi that are involved get out of the whole cooperation process?
Yes, so there is a symbiotic relationship, and they take about, it's like, it's an ATM, and they take a fee, because they take about 30% of what's exchanged, and they mostly get sugars from the trees, and they can use that as fuel to look on the ground for their nutrients. But they act as a hub also between the trees.
Okay, he talked about deforestation. He is Deforest European, the hive mind of Ermis Sakharopoulos. And his amazing number of props. Right, next we have a nice Irish inversion. Ever since Ireland first took part in FameLab a few years back, they've done brilliantly, succeeding not only in someone Irish winning FameLab International for Ireland, but in someone Irish winning International FameLab for 3 other countries. Okay, it was Belgium, the Netherlands, and Luxembourg competing as one, but the point still holds. The Irish tend to do very well in FameLab, which makes it all the more impressive that the 2019 FameLab Ireland champion, Hayden Wilkinson, is from Australia. And only after spending the first 22 years of his life down there and getting a BAc from the University of Wollongong, known as the Gong for short, did he head for Ireland. Now, Oz to the Emerald Isle sounds like a journey involving a brightly coloured paved thoroughfare, a dog, and travelling companions all missing key internal organs. But for Hayden, it was worth it, not only because he is now deep into an MSc in medicine at University College there. He says he's deeply in love, no details of with whom, and deeply honoured to have won FameLab Ireland. May the road rise up to meet our Aussie Ireland FameLab winner, Hayden Wilkinson.
This is the story of twins Lulu and Nana. Born recently into a difficult world of climate change, plastic ocean, and quite possibly one of the worst seasons of Game of Thrones we have ever experienced. These 2 girls' births were something very special. They were they were 2 of a kind. They were the world's first designer babies. Now, Calvin Klein and Gucci stand aside. I'm talking about genetically modified babies. See, when these girls were just a single cell old, CRISPR technology was used to edit their genes, giving them resistance to HIV. Yes, you heard that right. CRISPR, like a crisp potato chip, but CRISPR. Clustered regularly interspaced short palindromic repeat technology for long, or CRISPR for short, is so specific and so crisp that it allowed a single CCR5 gene in the twins' DNA to be edited. And this technology actually originated in a process occurring in bacteria. See, when bacteria are infected with a virus, they scan their DNA memory bank, the CRISPR region, for DNA matching the virus DNA. When they find it, a copy is made, and this copy binds to Cas9, a huge yellow googly-eyed murderous protein. Together, the Cas9 DNA combinations seek out the virus with the matching DNA, and, well, you guessed it, waka, 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 Cas9 eats the virus and saves the day. But so what? these babies are not bacteria as adorable as baby bacteria would be. How does this relate to the twins? Well, by reverse engineering our Cas9 friend here, we can feed it any DNA sequence that we would like, and it'll seek out the complementary genes in our own DNA. Cas9, rather than eating us, will edit us. So was the case for Lulu and Nana. They became HIV resistant today. But what of tomorrow? Well, you might want to go away right now and make your own army of smarter, stronger, muscly, genius Terminator babies and throw away your old babies. We must first think of the children. Like a tiny drop of water into a vast ocean, news of the girls' modification has already rippled out into a sea of skeptics. The scientists responsible for this DIY baby renovation show operated under a cloud of secrecy the entire time. They poorly edited the twins' genes in the first place, and when you look at it, they didn't actually fix any problems. The girls would have been born healthy, and with the right education, wouldn't have contracted HIV. Now, who knows what consequences this might cause? There are links to infection from viruses and bacterial infections that might be just around the corner for our poor twins. So, I think, in the end, we've got the good. Lulu and Nana are HIV resistant today and have paved the way for genetic modification. We've got the bad. While they may be HIV resistant, they're now susceptible to many other diseases. And we've got the ugly. Much like my Eurovision 2020 audition tape, the world is just not ready yet. Thank you.
So I will just state to the last sentence, the world is not ready yet. It's been a lot of, it's a hot topic, right?
Yeah,
what
absolutely,
you have chosen. Yeah. And there are a lot of ethical ramifications.
Yeah.
So can you say something more about this?
Yeah.
Part of not being ready.
Yeah. So at the moment, it's currently illegal to be testing on human embryos and then having them be born. And the scientist responsible, his name is Jingke. Sorry if I'm mispronouncing out any Chinese in the room. He operated, like I said, under a cloud of secrecy and did it even though it's illegal, and it's illegal in China. And while it is illegal as well, it's almost like he acted as the role of sort of God, and he was playing like with a magnifying glass, editing these sort of genes willy-nilly. But I think as well, not enough knowledge has been put into what happens in the long run. These genes are now going to be in every single one of the cells of the twins, and when they reproduce, they will pass on those cells, and we don't know if these cells, if these modifications might give a bunch of other diseases we're not aware of yet. So it's just very dangerous at the moment. While it is an exciting technology, and I think it would be good to, cure HIV and other diseases, there is not enough research done yet, and I think that's why it's illegal.
Why is this research exciting for you?
Yeah, so that's a good question. It's not my research field. I studied glycobiology, so it's a study of sugars. As exciting as that sounds, I really liked. I think I'm vegan myself. So how do you know someone's vegan? They'll tell you. But I've always really liked the cross section of science and ethics, really. And I think with veganism, I get that cross section. It's obviously a very hot topic to do with animals and everything. But I thought it would be very applicable to the ethics of controlling a life that's not yours. It's someone else's life, and now we're putting it in our own hands. As I was saying, we're acting as God. And I think that's such a hot topic for me, so that's why I talked about it.
Okay, genetically edited, 3 minutes.
Sorry then.
Aussie-born, Irish champion, and vegan by nature, Hayden Wilkinson. And if you're paying close attention by now, you'll realise we've had a Schubert and a Haydn, or a Hayden, but will either be Bach for tomorrow's final. Now, one of my favourite bits of FameLab Tremis is now where I once again get to use the word anti-penultimate as we come to our winner from Portugal, Rui Carvalho, who is, last but two, anti-penultimate, 7 of 9, not in the Star Trek sense, in these 3 Tremi finals. Now, Rui is a realist. He says, I have friends, family, a roof over my head, and a job. And in the world we live in, that's not bad. Now, this philosophy extends to his work as a PhD student, looking at how visiting tourists affect the unique rainforests of the Azores, which are about, 1,400 kilometres or so west of Portugal. Rui does it, he claims, not so much to have a steady job, but so he could find about the primal forces of nature. He believes any day is a happy day, providing you can make time for an inspiring conversation about science with a sense of humour and a bit of originality. And even 3 minutes can be just enough. Some Azores roars of please for Portuguese are here to please you, Rui Carvalho.
Dear humans, yesterday was the end of hope. Hope was the daddy long legs of the species Pholcus phalangioides, such as myself. And since yesterday, she is no longer amongst us. She was there, on that corner, eating a mosquito, when suddenly a human comes jabbering about disgusting animals and there were pieces of her on the wall. He didn't even want to eat her. And she knew so much. She lived for 2 years in the office of a scientist. She was the one who told us that there are 43,000 species of spider in the world. And of those, less than 1% are dangerous to humans. And also, we are on this planet for 300 million years, much before what's the name of these giant lizards your juveniles worship? Yes, exactly. And we are nearly on every ecosystem, from underwater to 6,000 meters, from the deserts to the negative 71 centigrades of the coldest city on Earth. We have there 55 species that live there without coats. And if you think we are antisocial, then some of us live in communities of 50,000 individuals who share hunting and parental care. Speaking of parental care, I want to ask the males in this room if they are willing to offer themselves to be eaten to the female after sex so that their offspring can grow stronger. Anybody? No? Okay, I thought so. And the simple act of making a web. From a liquid inside of you, of us, we can, in contact with air, produce a solid that it can then shape in the geometry you want. Or, as you rookie species call it, 3D printing. But still, it's hard for you to enjoy the privilege of having a wild animal at your home, at your reach. You don't have to be scientists. You have to be curious, to observe, to want to learn about us. We are not asking to be loved, but we do need to be respected. My name is Melissa. This is my deceased friend. Yesterday, I learned that sometimes unfounded fear can lead to horrible actions. So I am here to offer you a solution. Go to your houses, choose a spider, give her a name. And both of you start on a journey from fear to curiosity. Or, as Plato said, shall we get out of this cave together?
So I see that you're sort of making a plea for spiders, but why would it matter if we killed all the spiders? What would happen?
Well, I think that we humans now spend so much money, invest so much time in things that do not really sometimes connect to our deepest feelings. But sometimes at our own houses, some people feel fear, a very primal reaction. And what I'm saying is that even though movies and sometimes the media promote this fear, what I'm stating is that science, by telling us how to differentiate, by telling us the amazing things they do, can give a way out of this fear and turn it into something else more positive.
Is it related to your research, the topic you have chosen?
Yes.
It is. You are working on it?
Yes, I am a neurotechnologist for 15 years now.
Okay.
And how have you come to put your presentation in this way? If you've been working on it for so long, why tell the personal story in this way?
Because the first time this came up was as a project, so that I could reach other people about stop feeling fear for spiders. And this is actually a project for a children's book called You Should Be Old Enough Not to Be Afraid of Spiders. The title is directed to the adults. And we want the book to contain a message for the adults that's not understandable because of the references we give. And it's very easy to understand to the kids. But we want to educate the parents and the kids at the same time with the same book. And this is why also we have this kind of props.
Thank you.
Okay, arachnophile who made us smile, Portugal's Rui Carvalho and his enormous prop. It's fantastic to bring on something so huge and just leave it there as a corpse throughout as well. So he was the winner in his national final, but will he be a winner or a Portugallant loser today? We will find out soon enough as we come to the last but one of our 25 international FameLabers, and it's our South African champion, Kenilwe Moropa. Now, Kenilwe says her journey down the yellow brick road of science, that's our second Wizard of Oz reference, so she says her journey down the yellow brick road of science can all be traced back to 7 words spoken to her by her grandmother, spoken each and every time she was dropped off at preschool. Make sure you keep this child busy. Now, according to Kenilwe, this was no instruction, it was, quote, a disclaimer, alerting anybody within earshot I was a curious mess that had never-ending questions. Now, propelled by those 7 words down the aforementioned brightly coloured paved thoroughfare, Kenilwe is now studying analytical chemistry at Johannesburg University. As she says, what better way is there to find answers about the world than to analyse it at a molecular level? And what better way to share what she's found than by entering and winning FameLab South Africa? Our penultimate participant in these tremi-finals, Kenilwe Moropa.
Indulge me for a second. Let's all imagine a world where money doesn't exist anymore. That's right. No more pounds, no dollars, no stock exchanges, and no more Bitcoin. But rather, let's imagine a world where we're all flung back into the dark ages, and now we're bartering for our everyday essentials, like our clothes, our food, and even our medication. With this, water. A world where liquid is king. And depending on who you are, where you live, and who your president is, this might just be your take-home salary at the end of the month. After taxes, of course. Now, I know I'm starting to sound like one of those crazy end-of-the-world conspiracy scientists, right? But in actual fact, in 2001, the UN Population Fund warned that if we keep using our water as irresponsibly as we are right now, the globe will begin to run out of fresh water by the year 2050. That's 31 years from now. But before you all just start running out of here to go build your doomsday bunkers, give me 2 minutes, right? Because we can still turn this around. And that is where my work comes in. I work in the field of nanotechnology, which means that I work with materials that have dimensions and tolerances of less than 100 nanometers, or 10 to the minus 9 meters. So just to put that into perspective for you guys, that means that the stuff I work with is so small, it could be about the size of an ant's eyelashes, if ants had eyelashes. And what we do is, we take these materials, right, and we fuse them to everyday waste material that you wouldn't give a second look to. Things like clay, leaves, and even banana peels. And once we fuse and combine our nanomaterials to the surface of our waste, we now have a totally new product. Products I like to call super materials, because they now have the ability to remove all sorts of pollutants from water, from things like oil to nasty bacteria and infections like E. coli, even heavy metals. And we all know that metals can rot you from the inside out, right? But my best and most favorite part about my super nanomaterials is that they're reusable. And depending on how the super material is tailored and manufactured, it either filters out, attracts, or completely just annihilates the pollutants from the water. They save us time, money, and most importantly, energy. Now, over the past couple of centuries, us as human beings have come up with the biggest ideas, from fire, drilling for oil and gas, Twitter, crazy hair, and all sorts of things. But all these big ideas have very real big consequences. And one of those consequences is water pollution. And in order to save the world and save ourselves, essentially, we need to solve our problems in a different way. We need to start thinking differently about the way we solve our problems. We need to start thinking smaller. We need to start thinking nano. Thank you.
Hi. So you mentioned about the urgency and the need for this because of this 2050 scary deadline. So, yeah, doomsday. How do you see your research progressing in the near future?
Because water is one of those things that we can't make, unfortunately. So we need to reuse and recycle. So my research is important because I work specifically with clay and removing heavy metals from industrial mine waste. So all that water that's been polluted from the mines, we can actually take it, remove all the heavy metals, and then put it back into communities that actually need it. Especially for me, because I come from a country where access to clean water is sort of a privilege. So we can take water that's actually being polluted by industries that don't really care about the people, take that water, clean it out, and then give it out to the people.
How do you clean it? You mentioned the super nanomaterials, yes, that they remove the pollutants, but what's the scientific process that this is happening?
So depending on what kind of pollutant you're removing, for instance, you could be removing E. coli. So E. coli, you'd need a silver-plated nanomaterial, and then the silver kills the E. coli in the water. For me, I remove heavy metals. So I take clay, I fuse some nano materials on there, and then the clay then attracts all the heavy metals towards it. And once you're done, you filter out the clay that has all the heavy metals, and you've got clean water.
Okay.
What do you do with all the heavy metals you end up with as well, though?
Ah, that's the interesting part. Thank you. So all those heavy metals are then now taken to other industries that use metals for other processes. So we don't put them back into the environment, we reuse.
Great. Great.
Okay, perfect point to stop us.
Thank you.
From Kaniwe Maropa. I love the fact Kaniwe said we need to start thinking smaller as she went past the 3-minute, 15-second mark. So you do need to start thinking smaller. That just leaves the last, but statistically unlikely to be least of all 25 FameLabbers, and that is our Switzerland winner, Ottman Akwisi. Now, continuing one of this competition's great traditions, which is that the Swiss winner is never from Switzerland, Ottman is Italian of Moroccan descent and is a PhD student at EPFL in Lausanne. He says he's always been fascinated by the relationship between electricity and humans, just like the great Italian scientist Luigi Galvani, or perhaps more famously, Victor Frankenstein. Ottman even suggests his fuzzy hair is the result of excessive electrical shocks during his crazy experiments. I stress these are his words. Fortunately, rather than all this leading to late-night grave-digging excursions and villagers with pitchforks, Ottman's fuzzy hair and not-so-fuzzy logic has now been applied to developing implantable electronics like bionic limbs and to galving others by taking part in and winning FameLab. He's 25th of 25 Tremie finalists, but no pressure for a big finish for FameLab Switzerland winner Ottman Akwisi.
Smartphones, smartwatches, smart washing machines, everything is getting smarter by getting more connected. But can we get smarter? Can we get connected? What might have sounded as science fiction more than 70 years ago, today is a solid reality. I'm talking about brain-machine interfaces, a technology developed together by doctors, engineers, and scientists to link the human brain with machines and computers. But how do they work? We can imagine as if our brain was an orchestra playing in a concert hall that is our skull. This orchestra is made of more than 100 billion musicians, 100 billion neurons communicating to each other through electrical impulses, like a computer does. Now, imagine you're a poor student like me. You cannot afford a ticket for this concert hall. So you sit outside and you listen. From there, you would only perceive the symphony, but not the details, maybe the humming. This is equivalent to a technology called electroencephalography, where electrodes are placed above the skull to monitor the activity of neurons all together on the surface of the brain. This non-invasive technology allows us to monitor the level of focus of kids with attention disorder, or monitor the quality of sleep of patients with insomnia. Some even crazy scientists try to use the same electrodes to apply electrical stimuli. This improved up to 15% the memory performance of some patients. Now, what if you have money and you can enter this concert hall? This is possible thanks to implants. These implants can get thinner than a hair and can be inserted into the brain. There, they would get in contact with up to single neurons. This is equivalent to entering the concert hall and sitting in front of the main violin. You would perceive every single note. Thanks to these technologies, we've been able to give back voice to completely paralyzed patients by monitoring the activity of neurons linked to vocal cords. Now, maybe it's a little bit too early for brain-machine interfaces to make us smarter, but surely we can get smarter another way, by curiosity, research, and most of all, the human-to-human connection. Thank you.
So you say you put something inside the brain, an implant, and then this implant talks to the neuron. How does it work?
So as I said, the brain communicates with electricity, and these devices are developed thanks to the technologies borrowed from the microelectronics, the same industry that makes our phones. So we implant these wires that are metallic and covered with special materials to intercept these electrical signals. And then with algorithms and like highly complex computation, we can reverse engineer ourselves and understand how what's the intention, for example, of a paralyzed patient when he's thinking about something. And it's currently working and being used in humans as well as experiments.
If we did manage to get to the stage where we could increase intelligence, although what we mean by intelligence is a bit of a difficult point, but let's just say we could, by using implants, what do you think the ethical implications of that might be?
I remember a great philosopher said, with great power comes great responsibility. And this is the truth, actually. As scientists, we strive to find answers, and we provide tools to the community. How to use it later, it's more of a community problem that we have to discuss as researchers, as public, and as politics as well, although it might be difficult without proper communication.
Okay. And are there any other things that you, in the future, would love to see this technology make possible?
So the future is getting closer and closer. Patients have been able to walk again after complete paralysis by taking signals from the spinal cord, the brain, and the nerves, and they've been able to walk again. Actually, in my university, they're pioneers in this field. The possibilities are endless. I mean, these technologies can also cure important diseases as OCDs, as obsessive compulsive disorders, by applying stimuli directly inside the brain thanks to what is called deep brain stimulation. Electrodes are inserted deep into the brain, you give some precise shocks, and a depressed patient can get happy again. But it's extremely complicated. Inserting a wire into the brain is like if an alien spaceship came into Cheltenham and we would be like all crazy, going mad, and the immune system reacts to this implant, attacks it, tries to remove it, and us as scientists are kind of trying to make peace between the brain and what's coming from outside.
Brilliant work to get an alien invasion into his last answer. Orchestral manoeuvres in the dark of our brain from Otman Akwisi. So, he's our Swiss champion. Was he a Swiss hit or a Swiss miss? That is largely for our judges to decide, and to do so quickly, which means Katarina Cowrie, Ginny Smith, Lizzie Daly, go fuse wisdom and whizziness as fast as you possibly can. Back here, please, in about 5 minutes with your 3 from 9 to make it through. And can we usher and rush them on their way with some applause, please? Now, while they are being collectively selective, we need to be even more picky. Just one, please, one Tremi finalist who will go through to the final as your audience vote winner. If you and the judges are in harmony and plump for someone who is also one of their trio, so be it. If you go for somebody different, well, they'll go through as well. Now, here's what you do first, as it's telling you up there. Get out your internet-enabled device. If you've got multiple devices, please just stick with one. If you've got no such device, sorry. The network is CF voting. The cunning password is Science 2019. You can do this just by 3G or 4G if you want. Then go to the VoxVote website, live.voxvote.com. And then while doing that, at the risk of going beyond the load-bearing capacity of the stage, can we get all 9 FameLabbers back up here to a burst of applause, please? Welcome back, Australian champion, but Italian insect inspector Paolo Magni, Czech Republic's experimental botanist Lucas Marishka, German geoscientist Tora Schubert, a double Dutch combo of black holes and barytonatium dancer Thera Menon, Greek geek who likes to speak Miss Sakaropoulos, Irish champion but Australian medic Hayden Wilkinson, works in the Azores but never bores Portugal's Ria Carvalho, South African champion down to the molecular level Kenewewe Moropa, and Italian but here is a Swiss winner. Oh, finally there, Otman Akwisi. I think we just got. Can you shuffle down very slightly? Even those are lovely shoes, you can squeeze them slightly more closely together. Now, if you've been here since 4:30, you've seen 9 bits of brilliance, 9 FameLabulous FameLabbers, and if you've been here since 10 a.m., you've seen 25. The standards have been amazing, but I think you've seen a whole quality of science communication crammed into one amazing day. So can we have a collective round of applause, not just for the 9 here, but for the 25 over the day? So, hopefully by now you've gone there, you've done your voting-y type thing. If you want a last chance to influence people, anybody still need another couple of seconds to vote, or are you all voted? Make a mumble if you've not voted yet. Well, that's the not voted yet. Are you going to vote? Yeah, okay, so we need that combination of mumble. Okay, last chance to influence them. Right, now remember, that's great. And please, I've stressed this in the previous 2 Tremi finals, but please vote for who you think has been best on the day, not who might be best to go for a drink with, or who is your best friend, or comes from the best country. Just go for the person. It's best just to vote who was most FameLabulous in their presentation. Right? If you haven't voted yet, you've got a couple more minutes to do now as we show you a video. If we can get everybody having got you back on the stage, the next time you come back here, instead of this united, harmonious group, you will be a disunited mob. So, we've got one last FameLab video to show you.
FameLab is amazing because it's one of the things I've always wanted to do since I was a little girl, which is to represent a female Muslim scientist. And I can't think of a better stage to be seen than on FameLab.
I'm really proud of myself, which I really am not most of the times, but now I'm really proud of myself.
To be here representing my country has been such an overwhelming and humbling and amazing experience.
It was a great opportunity to meet new people, not only here in the final, but also back home in our national final.
I learned how not to be that competitive, because I generally am a bit. So here with this whole atmosphere of FameLab that is all friendly and nice, I don't really care if I win.
FameLab has helped my personal development. As a researcher, sometimes you get tired and weary. I don't want to glamorize science and say everything is hunky-dory. Sometimes your research is not going the way that you want it to go. Sometimes experiments fail. But when you see how your work relates to other people, when you see how your work is impactful to the community, it gives you new strength, it gives you a boost.
I've learned that there's a lot of research projects that I had no idea existed. I also was able to meet a lot of wonderful and international colleagues around the world.
I think for me the biggest thing is diversity of voices, and this kind of actually shows the range of different people that are going into doing science research.
If you're thinking of applying for FameLab and you think you don't fit a certain criteria, just forget about it. As long as you have a story, you have something to say about your science, then you should go for it and just figure out the rest along the way. And I think it'll be an amazing experience.
Been some great videos. Well, as they say, video killed the radio star, but who kills the hopes of our FameLab stars? Why, it's the judges, and hopefully they're on their way back now to wield their axe. Judges, we're ready. It's going to be a bit anticlimactic without you. Okay, we appear to have no judges. There's someone nudging the judges into making a decision. They were given a pretty precise time frame to work to. Judges! Okay, in the absence of judges, it's a bit anticlimactic, there's nowhere else to go. I'm going to reveal oh, hang on. I think they might have been nudged into activity. Are they coming? They're really building up their entrance now. Can we please have a round of applause as they speed towards the stage for Lizzie Daly, Katerina Cowrie, and Ginny Smith. Okay, there's only one flaw in this. They've not actually come. I don't know if anybody noticed. Okay, they were coming, but now they're not coming, or maybe they are coming. Is they coming this time? Neither of you are judges. It's the world's slowest judges. Come on up. Now, we gave you one thing to do. One thing.
Oh, that was so hard.
One thing.
One of the most difficult things.
Yeah,
we know.
So fast.
But that's the idea. Yeah. It's not difficult if you have all day. We know these are momentous decisions and you take your responsibility incredibly seriously. But apparently over 40% of the audience have some sort of lives to go to after this. So we need to be able to let them out. So first question, clearly, tricky decision.
Yes, and we didn't all agree on everything. So we had to sort of take votes and go with majorities.
Oh, God, this is kind of like rock, paper, scissors?
Yeah.
Or...
There was a couple of punches thrown. It was all very dramatic.
Right, okay, some serious bruising. But you've reached a sort of reasonable, acceptable kind of compromise, but you may never speak to each other again.
Yes.
Something like that. Yes. Okay, so what we want you to do, I don't know if you want to do it one each, or especially if you all disagree. Now remember, try and keep some element of mystery by not blurting out the name Roger Highfield stylely. So who wants to go first?
I'll go first.
Right.
Yes. Okay, so this is a topic that I know absolutely nothing about. I think that the story was told in a very clear and very very clear and engaging way, I'd say. And for me, I think its importance is huge, and it just really inspired me. And I came away thinking about the importance of something that perhaps before I wouldn't really have put on the priority list.
So you didn't know anything about it before, but now you know a bit and you want to know more, which is the nature of great communication.
And actually, I'm inspired to actually do something towards it or help learn or learn more about it generally. Have I kept that vague enough?
I think that's great. That's very vague. It could be any of them.
It's just real-world applications, really important, and I just thought it was fantastic talk in itself as well. It was actually contestant number 8 from South Africa. So I hope you say your name right. Kenilwe. Yeah.
Hey, come on up. Woo! Hey! Woo! Congratulations. That was good. Right, okay.
Well done.
Okay. So I don't know if I'm gonna do so well, but
you're not being judged. You're judging. It's fine.
So it was again about a great story that linked the far away with the near, and I think we all agreed on that.
Yep.
And it's about stars, so I might as well say who it is. Contestant number 4 from Netherlands.
Okay.
Yes.
Can it come up? Okay, congratulations. Okay, and that just leaves.
Just the last one. So this person took to the stage and I think just immediately kind of filled the space around them. And they also used humour quite entertainingly to talk about what is a really difficult and really very important topic. So I will put you out of your misery. The final contestant going through from Germany is Thora Schubert.
Hey! Tora, congratulations as well. Well, we say the final contestant going through, of course.
Oh, from us.
From you, yes. But there is another higher calling here, which is the audience. Now, as I say, you might have picked one of these 3. You might have picked somebody else. Let's not draw it out. It's been a long day. And it's a really lovely gold envelope. And the good news, for those of you who like long finals with lots of people, is it's not one of these 3. And there is no bad news. It is from Australia, Paolo Magni. Woo! So once again, you've maintained a fantastic tradition. Every single time we've done this, except the second Tremi-final today, the audience have always disagreed with the judges. And of course, you have the wisdom of crowds, whereas they're just 3 individuals, so you're clearly right. So it's brilliant. So we now have, by my reckoning, a final that is Australia, Bangladesh, Egypt, Germany, Korea, Malaysia, the Netherlands, Romania, South Africa, Thailand, and the UK. And what's impressive is that was in alphabetical order as well. So what we're going to have now is the final act of these Tremi-finals. Is what we don't know is what order you're all going to go into. So we have a FameLab bag here, which is what Adrian's carrying. He's not the FameLab bag, let's be clear. So this is Adrian Fenton, who is senior consultant at the British Council and also kind of FameLab guru. So in that bag you've already got the existing names, and you're about to add these new names, 4 more, to make a final of 11. Is someone taking notes? Yeah. Good. Okay, shall we get you to draw them? I mean, you can go if you think this is boring. This is drama at the end here.
Right, so first up.
So this is first up?
Is Germany.
Germany. Da, 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 da. Germany first. I've heard that somewhere before. Right, okay. Second up, Australia. Don't put the names back in the bag, Adrian. Oh, fine, I'm just checking. Right.
Third up, Netherlands.
Netherlands, woo! It's amazing. You're doing well, big on stage. Maybe they didn't go deep enough into the bag. Yeah. Too late now.
Fourth up is the UK.
Fourth up, UK. Hey. Woo!
All right, let's have a bit of a rummage slightly deeper. Right, next up is Thailand.
Thailand, woo! It's worth a round of applause. Just
yeah.
And then we've got Bangladesh.
Woo!
Right. Yeah. Next up, Lithuania. No, they're not in the competition this year. So.
Romania.
Romania.
I'm not sure how you got left there.
How many's the Romania remainder?
Yeah,
right,
indeed,
right.
indeed. South Africa next.
Yay! That's every.
This might be the last.
How many names you got written down, Kathy?
Okay, 2.
There are 3 more.
Well, let's hope there's 3 more, isn't there?
If there isn't, that's going to be called. It could be
Egypt is next up.
Egypt. There are 2 more names left. You'll be glad to know.
High-tech methods. And next up is Korea.
And by a process of elimination, is it Malaysia?
Let's hope so. Last but no means least.
Yes, he worked it out, Malaysia. That worked out fantastic. Can we thank Adrian? Can we congratulate our 4 winners? So I will see them and the other 7 finalists in the town hall tomorrow night, starting at, what time is it? 8 o'clock? 7 o'clock? Can't remember. Anyway, it's 8:30. It's £10 fee if you haven't got your tickets yet. Please go and get them. It's a really great event. Thank you for coming. I am the little bit that is left of Quentin Cooper. It's been a pleasure to have you. Can we thank our judges? Can we thank the backstage team? Can we thank British Council? Can we thank Farah? But most of all, our 4 winners from Tremie Final 3. Thank you very much. This has been the Tremies.
I should grow up someday, 'cause I got bills to pay. I can't be waking up at someone else's